morning, everyone. I'm Francesca Little. I'm from the Department of Statistical Sciences. And for the next 10 or 15 minutes, I would like to tell you why you may consider a career in the mathematical sciences, statistical sciences, and of course, what we call these days, data science. I hope you can hear me. I can't see you. We're in this terrible online environment. It would have been so nice to have met you on campus this morning. But as you can see, this title of this talk kind of refers to the statistical revolution. It refers to data science. It refers to going from data to decisions. And I'm going to try and explain all of that to you in the next 10 or 15 minutes. So we are surrounded by data these days. There is data everywhere. Every time you swipe your credit card, you're generating data. Every time you're using Facebook, you're generating data. Even driving your car, leaving a voicemail or visiting a doctor, you are creating data. And that's just a single person. If you put all that together and you look at all the humans, you look at all the corporations and the organizations in the world, from healthcare to social media to industry, just think about all the data that is being generated. And then we get to the scientific experiments, and we are in the science faculty, of course, and think about all the research happening in medicine, ecology, and astronomy, all of which generates data. So there, you are used to data in the financial world. That is probably the one that we're all familiar with. If you look in the newspapers, you'll see these kind of graphs and more based on data that's trying to predict what's going to happen to your money. In South Africa, we do a lot of research in biology. You know about the problem with the poaching of rhinos, and that's just one of the many ways in which you can generate data based on animal ecology. Every day you look on your cell phones and you see what the weather is going to do, and that is based on data, past data that you use in prediction models to try and say what is going to happen today, tomorrow, next week. More biology. We live in the Western Cape. How many of you like surfing in False Bay, near Fish Hoek, that area? A few years ago, we were involved in a study that was counting the number of sharks there and when they were there. And I think it's changed since then, but certainly at that stage, there were very many, and they were there all the time. Satellite monitoring has become a very important way in which you gather data, and of course one of the ways in which it can gather data is about the fynbos vegetation or the general vegetation in our natural parks, and don't we remember the fire of a few weeks ago that affected UCT also quite drastically. Then when you shop, every time you're at Pick n Pay, ShopRite, Checkers, Woolworths, they ask you whether you've got a loyalty card. And you think that because you have a loyalty card, you get lots of discounts, but you don't get those discounts for free. At the same time, they're gathering information about your shopping habits so that they can strategize their marketing strategies towards your behavior and hopefully sell you more stuff. I've spoken about social media, the Facebooks, the Twitters, the YouTubes, that generates more data than you could ever imagine. Cricket is the statistician's sport and really creates so many different statistics that can be analyzed, manipulated, talked over while the players get on very slowly with their games. So there's a lot of statistics, a lot of numbers being generated, not only, of course, by cricket, but by other sports as well. And then we have been totally inundated with data, with statistics, with models, with analyses during the past 2 years related to the COVID pandemic. And I think if people weren't aware of data and of what modeling of data and analysis of data can achieve and how important it is, they certainly have become much more aware of it in the past 18 months or so. So I've shown you that there is data everywhere. There is a lot of it. We talk of the volume. There are many different kinds. We talk of the variety. It comes in very fast. That refers to the velocity. And it is not definite. There is a lot of uncertainty in the data. So we talk of the 4 V's of data. It's all good for the data to be there, but it's not any helpful at all if it's just there and we don't do anything with it. We want to take all that data and all the information contained in that data, and we want to make decisions based on the information contained in that data. And that is where statisticians, data scientists come in. What you need to be able to turn the data into useful decisions is complex thinking. You need statistical modeling, you need quantitative problem solving, and all of that go together with imaginative computing. And if you put all those 4 things together, it's like a detective story with very skillful detectives doing their bit. You will come up with information that has turned that data into something that you can use for making important decisions in the area in which you are working. So, having told you what the problem is, let's focus on the people who are involved in this area, the people who are going to take this data and turn it into decisions. So, what is statistics and what does a statistician do? Or these days, we refer to statistics very often as data science. What is data science and what does a data scientist do? And I've got 2 paragraphs or phrases here. The first one is informative, but rather dull. A statistician is someone who works with theoretical or applied statistics. The profession exists in both the private and public sectors. It's common to combine statistical knowledge with expertise in other subjects. Typical work includes collaborating with scientists, mathematical modeling, simulation, experiments, forecasting future events. That is all true, but you may have fallen asleep in the meantime. What we really do is the following. Data scientists are inquisitive, exploring, asking questions, doing what-if analysis, questioning existing assumptions and processes. And armed with data and analytical results, a top-tier data scientist will then communicate informed conclusions and recommendations across an organizational leadership structure. Doesn't that sound like fun and so much more interesting and so much more important? And that describes the day-to-day life of a data scientist. So what do statisticians or data scientists do? I think I have kind of tried to already say that, and this just confirms it. We have to collect the data. We then have to use that data and use it to estimate and model uncertain quantities, which we will then summarize so that we can draw meaningful conclusions, which again illustrates this cycle from data to decision making. So who should consider becoming a statistician or a data scientist? If you're now a matric or grade 11 at school, what should you be interested in and what should your skills be if you think this might be the job for you? It is, of course, very much grounded in the mathematical sciences, and so you should have a strong aptitude for mathematics. But you would also be interested in a challenging career, in job satisfaction, in excellent opportunities. You also would like to use your mathematics to work with other people and solve important problems. And I think that, to me, is the most amazing characteristic of my very long career as a statistician, is the fact that I do not sit in an office on my own and either work out theoretical derivations or sit behind a computer and program away all on my own writing algorithms. I work with people. I get data from people. Yes, I use the computer and my mathematical derivations and algorithms and results to then model this data to answer the questions, the important questions that are out there in the area that I'm working in. And that is the rewarding bit of being a statistician or a data scientist. The fact that you can use your mathematics to work with people to solve important problems. You will be able to apply that in a wide variety of fields. And as you can see, the slide lists the number of fields from agriculture to law, to business, to the health sciences, to ecology and sport. You can pick and choose where you would like to use your skills to answer these questions that we have been referring to. You may not be called a statistician. In fact, these days, you're more likely to be called a data scientist than a statistician, but even that might not be your job title. There are very many different kind of job titles out there that you will be called, but actually you are busy doing statistics or data science. So that's also something to remember when you start job hunting, is to throw the net wide. Though these days, I have to say, in the last 5 years or so, the common advertisement or job title, the person they ask for is a data scientist. There is a lot of recognition out there that data scientists and statisticians, people with a mathematical ability and the ability to work with data and model the data, are important people and are very much in need. These are relatively old quotes, but they still hold today. And you'll see as I go on that very much, especially in the world we live in today, where jobs are scarce due to economic conditions and due to the pandemic. On the whole, if you have got the skills of a data scientist or a statistician or a mathematical modeler, you're going to get a job. You can see we really like Hal Varian, Google's chief economist, who called us called statistics the sexy job in the next 10 years. So we've passed those 10 years. People think I'm joking, but we would have guessed that computer engineers would have been the sexy job of the 1990s. The ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it. That is going to be a hugely important skill in the next decades. And it is so true. Further, another quote from The Economist in 2010, a new kind of professional has emerged, the data scientist, who combines the skills of software programmer, statistician, and storyteller/artist to extract the nuggets of gold hidden under mountains of data. And both those quotes again illustrate to you the kind of skills that you're going to need. You are going to need to be able to program. But you're not only going to need to be able to program, you're going to need to know how to work with data and model the data. So the job of a statistician. And then you're going to need to be that decision maker to be able to say, what does all of this mean? And tell us about the problem we were analyzing. So in June 2018, there was an article that looked at the growth of jobs in the next decade or so. And what was very interesting was the growth that they predicted for careers in the mathematical sciences. And as we said, we're looking at a specific discipline within the mathematical sciences. And here you will see some mathematical sciences jobs referred to. There are, for example, actuaries, and I suspect that if you're listening to this talk today, you would also be considering becoming an actuary. There's a mathematician, there's an operations researcher, and there's a statistician. And the good thing about all of this is that all these jobs are predicted to grow quite substantially from 2016 to 2026. You can see the current kind of level of occupation and then what they predicted to be in 26, and maybe the best is to look at the percentage change. They're all increases. They're all very big increases. You can pick any of these careers. The statisticians are the highest, 33.8% predicted increase among these. So there you go. If you want to have a job, not only an interesting one, but the certainty of getting a job, become a statistician or a data scientist. So if I've convinced you by now that this is something you're interested in studying, how are you going to do that if you came to UCT? There are, of course, these days, several departments, several faculties that include an element of data science within their curricula, because data science is very much a collaborative science. It joins computer science, statistics, and what I call the domain science together. And those three units together will really give you the training you need to become a data scientist. In statistical sciences, we lead the data science programs or the big data science postgraduate program at the university. For undergrad level, you will come and study major in mathematical or applied statistics. You often have to do a dual major, and as we said, it's a collaborative science, so taking any other course with it, be it a biology, genetics, or finance course, is a good idea. You will, of course, study mathematics with it, and it's highly recommended that you also take computer science with it up to a certain level, first or second year level. And as we said, you will eventually major in statistics, be it mathematical or applied statistics. From there, you will carry on to a BSc Honours in Statistical Sciences, or any of our three taught master's courses in Advanced Analytics, Data Science, or Biostatistics. The options are yours. You need to have done pretty well in your mathematical sciences at school to be able to be admitted, but you've got that information elsewhere. To finish off, I think I totally agree with the quote by Tukey, a statistician from many years ago. The best thing about being a statistician is that you get to play in everyone else's backyard. And I can't emphasize enough the fact that this is the one mathematical science that is going to put you in touch with people and is going to put you in touch with interesting application areas. And you will be able to do your bit for our country and our continent. And whilst you can't read those bubbles there, each one of them refers to a project that was done by one of the academics in our department. So that's all from me. If you wish to find out more, then you've got our website, you've got our Facebook page, and you're more than welcome to email myself or our head of department, Freedom Gumetse, with your questions. With that, I'm going to finish this and wish you luck. I hope to see you on campus as opposed to the other side of a computer screen next year. Enjoy your day. Bye-bye.